Welcome back, my friend. My name is Krumox, and in this video we are going to see the solution for the Integrity's April 2023 CTF challenge. The challenge consists in this website, which has some hard-coded credential here, and there is not so much we can do, so just try to log in, strange, monkey, and as you can see there is some photos of bricks and nothing special on the source, just the URL for the image and a little piece of code that randomized the video when I click these buttons. The interesting part is that this site set for us two cookies, the username cookie and the account type. The username, even if changed to something like admin, doesn't do anything, and the account type is not an hash, not a base64 string. I don't know what it is at the moment. And we try with wrong credential, we have this error, and basically the website redirect us. Try again, as it redirect us to indexerror.php with the error parameter, and this string is reflected on the HTML, and it's XSS vulnerability here, but it's not useful in this challenge. Anyway, this error page has something useful, because if you look in the source code, there is this HTML comment that say they have to do remember to use strict comparison. But what is strict comparison? Basically, PHP has two ways to compare variables, a loose one and a strict one. With strict comparison, with the triple equals operator, you check for two variables to have the same type and the same values. But with the loose comparison, if there is a type mismatch, the PHP interpreter try to convert the second variable to the type of the first one. So, for example, if you have a string compared to a boolean, he casts the string to true if it's not an empty string, and to false if it's empty. Prior to PHP 8, there was this strange conversion between strings and numbers, so a string that not start with a numeric character is converted to the number 0. And this is dangerous, especially when working with JSON that let you send typed variables. Speaking about types, there is also another funny thing we can do. We can basically try to send array adding brackets, so the variables are not string anymore, but array. And if we refresh, we get this error, uncode type error MD5, argument first string must be type string, array given. So it's basically calculating the MD5 sum of one of these two variables. So we can try to delete the bracket here and refresh, and I think it's account type, and yes, it was account type, so it's calculating the MD5 of this variable. When talking about hashes and loose comparison in PHP, magic hashes came to my mind. So basically, when PHP see a string like this, starting with a number I and only numeric characters, it try to parse it as a number in scientific notation, and there is a pre-calculated value that when hashed give you this special string. So maybe setting the cookie to this stuff it's the key to unlock the next step for the challenge, and it is. The fun fact about these hashes is that if compared with each other, they are compared as numbers and not as a string, even if they are both strings. So if you have a challenge in which you have to guess two different values that give you the same MD5 hash, you can provide two values from this list, and they basically give them this type of string as a result that is evaluated to the 0 and 0 equal 0. Anyway, let's continue with the challenge. We expect the new image. It's base64 data and custom image.php. Try to catch the flag.txt. So basically it's leaking as a new endpoint. Let's try it. Okay, the gold wall image. Okay, so basically this endpoint output the same HTML that is included in the dashboard.php. So I think it's literally a PHP inclusion. But what is the sense to make a script to return us every time the same image? It's not make any sense. It's a custom image.php. If you have to include the same image every time, you just include with the hard-coded URL. So maybe there is a parameter I can use to make this script include a custom image. The page that it's shown to us if we type wrong credential was called index underscore error.php, and the error parameter was used to render some text. So maybe in a custom underscore image.php the secret parameter is image, and it's not. Maybe it's include, no, maybe it's file. Okay, we break something. So with a file parameter we got it, but we have permission denied. Maybe it's because it's an existing path. We can try with some basic inclusion payload, but it doesn't work. So let's just think about it and how it could be used in a legitimate way, so we can imagine what path the developer is trying to enforce on us and we try to escape it. So basically this is an endpoint to include a custom image, I suppose. So let's try with the path of the brick image. Let's copy, paste, error, file get contents on this path failed to open stream, no such file at directory. It's better, it's at least a PHP error and not a permission denied error. So maybe it's checking for these strings to appear on the path. So if you change a letter, permission denied, okay, it's definitely checking for this path to be present. Okay, and let's check for extension. Can I delete the extension? It's still valid. Yes, it's still valid. So we can try some path traversal, // flag.txt, and file get contents. It's opening www web image flag.txt. So it's stripping out this .. We can try to double them, but it's still not working. I tried even to pass an array as a parameter, and this revealed that is using string pose to checking for .. on the path we passed. Another thing to try is to use the backslash instead of the forward slash. So another one here, and we have to remove this bracket and this one, and we got an image, a broken one. But that's good, because this is the encoding in base64 of the flag.txt files. Just for the sake of curiosity, I put a slash here, making this path invalid, and we see this error, file get contents, www web image .. So PHP normalized the path from a Windows style to a Unix style, converting the backslash to normal slash, bypassing the string post check. So let's come back to the image. Let's copy paste this 64 blob in a terminal. Okay, I have already there with the coded. Hey Mario, the flag is in another path. Try to check here, and this long unguessable path, and we can try it. So let's go. Okay. We get there, but we got redirected to the login page. So maybe it's useful to try to leak the source code. So basically we can do it again. We take the base64, we decode it, and after that we have the source code of the page. The page is checking if we have a username cookie with the value of admin, and if not, it's redirecting us to the login page. After that, it takes our user agent, that is a string that a browser, or more generally a client, send to identify itself to the web server. it strip away this bad word from it and use it to generate a command that is passed to shell exec, that is a function that executes system command. And this is where the vulnerability is, because we are executing system command based on user input not properly sanitized, so we can do bad stuff here. So let's focus on the final step, so get code execution on the challenge. We are in the middle of an echo with a append operator to this file, and it's echo open quotes our input closed quotes. So in bash we can execute process when inside quotes using this operator, the dollar parentheses. I think it's called the process substitution operator. So for example, we can open a Linux terminal here and we can try with echo quotes dollar parentheses echo 123. The output of this command is substituted to the dollar parentheses stuff, and echo 123 is echo 123. Okay, it's working. Another stuff is that we can't use space, and bash has a particular variable for this. It's called internal field separator, I think. That is a variable that stores the value used for separate stuff. So echo the variable that contains space 123, it's echo 123. And for the fact that it's stripping away these bad words from the input, it's not a problem because it's not doing recursively. So if I want to use, for example, tail, I have to write tail with a tail in the middle. So when I find the first tail and delete it, it leaves the desired input in our user agent. So this is my final payload. I'm using process substitution to invoke netcat to basically send me a reverse shell on my IP address and my port, and I have to send this payload on a user agent header. So from the network tab we take the request and we copy as bash. I've started a listener on netcat here. I've copied the command there. I have to escape the dollar and the brackets because I'm using double quotes here instead of single quotes. Single quotes don't interpolate the variable inside of them, and I need the double quotes to use the IP variable to not leak my IP on the internet, basically. But if you are coded IP, you can just use the single quote and don't have to put this backslash everywhere. And we can run now the final command. We obtain the reverse shell ls. There is this strange file, and if we cut it, we obtain finally the flag. I really enjoyed this CTF because it was really black boxy, penetration test like. So a special thanks to Integrity to make it possible, and for this video that's all. Let me know if it was interesting. Please leave a suggestion or feedbacks down there in the section comment, because in the comment section, because this is my first video since a while and the first one in English, so I'm maybe a little bit rusty, and thanks for watching.